We live in a world of connected, intelligent devices called the Internet of Things. Consumer offerings such as wearables, smart home devices, and connected cars communicate with services over mobile and broadband networks, and sometimes over the Internet. While enterprises in diverse sectors such as manufacturing, transportation, energy, and utilities use smart meters and sensors, remotely controlled devices, and other remote automation solutions to deliver more cost-effective and efficient outcomes. But as more and more IoT devices connect to the Internet, the opportunities for hacking increase dramatically. Hacked devices can compromise the networks to which they are connected and can serve as a launchpad for botnet attacks, where thousands of these compromised devices can flood the network with traffic, taking down websites and slowing down communications, leading to denial of service in homes and enterprises. The sheer number of connected devices increases an enterprise's exposure to cyber threats, making the security of IoT devices and their communication channels essential to ensure that cyber breaches don't penetrate the rest of the enterprise's IT infrastructure. AT&T understands the security risks inherent in IoT and, as an experienced network provider, has various options for ensuring secure connectivity for IoT and other applications. Hackers typically scan for devices with ports open to the Internet, which may have been inadvertently or unknowingly left open to incoming traffic, and can then be used to compromise the device. One obvious deterrent is to place devices behind a NAT and firewall so that devices have private IP addresses, which cannot be accessed directly from the Internet. A private APN can be designed to restrict access from the Internet and implement a NAT and firewall. Thus, unless there is a compelling reason, an IoT device should not be given a public IP address, which allows external entities to directly reach it. Similarly, it is preferable to ensure that IP addresses are dynamically assigned. A device at a static IP address, once compromised, is vulnerable to hackers when orchestrating a botnet attack, or could be used to infiltrate the private network and compromise additional devices, allowing the theft of valuable personal or commercial data. A more secure approach is for a device to call out to a server on the network rather than leave open a listening port through which it can be contacted. If discovered by a hacker, this port could be used to compromise the device. A customer should set up a secure pipe, a VPN, to carry data from its IoT devices to its enterprise servers. An enterprise customer that wants additional security can use a private APN to route this data from the AT&T Mobility Broadband Network to the enterprise network. When an enterprise's servers are on a public cloud, AT&T's NetBond solution creates a private link from the AT&T broadband network to the cloud. Thus, with such options, an enterprise customer can ensure that its data is kept isolated and does not traverse the public internet at any stage. IoT devices are typically unattended and cannot log in to a remote service in the usual manner. A SIM-enabled IoT device offers a secure way for it to authenticate to a service. The SIM is provisioned by the mobility network to uniquely identify the device, while a certificate stored on the device contains the credentials with which it authenticates to the remote application. The certificate also contains information that can encrypt the data traffic to prevent eavesdropping. Thus, choosing an appropriate option for securing the communication channel for IoT devices is essential to ensure that cyber breaches don't penetrate the rest of the enterprise's IT infrastructure. It is important to understand what security benefits these options provide, and AT&T is ready to work with enterprises to help them strengthen and secure their IoT solutions. For more information on AT&T's security offerings, visit our website.